Welcome, ladies and gentlemen. So what I'd like to do is show you how to identify the vertex when given a quadratic equation in standard form. Now, there definitely is a way to be able to identify the vertex of an equation in standard form. However, I want to be able to show you how to do it using completing the square so we can rewrite it in vertex form. So just a quick little reminder, I'm going to have to erase this. There is some formulas, again, that we can use, which we'll get into later. But for algebraic method, if I wanted to ask to see what exactly they were, you need to have them in ax squared plus bx plus c. That is our standard form. And what we're going to do is we're going to rewrite our quadratic function in this case from standard form into vertex form, which is a times x minus h squared plus k. And that is vertex form. Okay? So basically what we're going to do this is we are going to use the process called completing the square. So basically the main important thing that I want you to see about this, the difference between these, they both have a squared. And if you were to expand, multiply x minus h squared, which would be x minus h times x minus h, you would end up getting an x squared. But the major difference about this is here you just have a single term, x squared, where here we have an expression that is being squared. And this expression being squared, what we call that is a binomial squared. Because basically that expression is two terms being separated by addition or subtraction in this case, and that expression is being squared. So it's called a binomial squared. So what we're going to do is the whole process of completing the square is basically rewriting our equation so that we can create a trinomial that we can factor to a binomial squared. And we kind of talked about that when we were looking into factoring, when we started factoring perfect square trinomials. And hopefully one thing that you trying to caught on, when factoring perfect square trinomials, that creates a binomial squared. So our goal is going to be to create a perfect square trinomial. So that's what I'm going to be doing for the rest of these. Ooh, I did two of them. OK, so let's go ahead and take a look and see how we can do this. So the first important thing when you are completing the square is we want to make sure that we complete the square where a is going to be equal to 1. Not negative 1, not 2, not 3, but a is equal to 1. So I'm going to do 3 examples when a is equal to 1 to kind of show you how to do it. All right, so the first thing we're going to do is we are going to group our quadratic and linear term. I'm going to do one at a time, but I don't know. And what we're going to do is we want to create a trinomial inside of these red parentheses that is going to be a perfect square trinomial. Because once we have a perfect square trinomial, we can factor it to a binomial squared, which is exactly what we want. Now, we can't just create that. It's not little magic, but it is kind of a math magic, as I might say. So basically what we're going to do is remember, shoot, I erased that. Well, remember, it's a x squared plus bx plus c, right? So that's your standard form. So we have this in standard form. We have a, b, and c. So what we're going to do to create our perfect square trinomial is we are going to take b and divide it by 2 and then square it. So I'm going to take b divided by 2 and square it. So in this case, I have 2 divided by 2 squared. Well, 2 divided by 2 is going to give me 1. 1 squared is equal to 1. Now, what I'm going to do is I'm going to add that 1 inside of this red parentheses to create a perfect square trinomial. So by doing that, I now obtain, let's use red parentheses here. I now obtain here x squared plus 2x. Now I'm going to add the 1. And then still have the minus 3 in the end. OK? So what I've done by doing b divided by 2 and squaring it, adding 1, basically what you can see here is I have now, this is a perfect square trinomial, which again I'll kind of explain in a little bit shorter term, and then we'll kind of go through some longer ones. Now, there's a couple important things here. This is an equation. F of x equals this. And just a reminder, whenever you add something, properties of quality, for instance, when I had, 3x minus 5 equals 15. If I'm going to add 5, I have to add 5 by both sides. That's called the property of equality. Well, in reality, if I'm going to subtract 5 and add 5, that's like the same, well, just a little different story. If I have x and I add 1, subtract 1, those are really undoing each other, right? That's equivalent. That is still equivalent to x. So as long as I add and subtract the same number, I'm still going to have the same values. Or you can do the same operation to both sides, and you'll have equivalent expression or equations. Well, I don't really want to add 1 to f of x. So what I'm going to do is, since I'm adding 1 to this side, I'm also going to subtract 1 to that side. Okay? So that's just keeping my function equal, basically, to the original standard form. Now I need to go back and factor. Now, I'm going to show you the first factoring rule, because this is a trinomial. But basically, what we're going to do here is we'll start getting to these. You'll start seeing a pattern. And then, especially once you start getting to fractions, following the pattern is a lot easier than following the factoring technique. But basically, if you remember the factoring technique, when we're factoring a trinomial in this case, what you're trying to do is multiply, see what two numbers multiply to give you c, but then add to give you b. So what two numbers multiply to give me 1, but then add to give me 2? Well, the obvious answer in that case is going to be 1 and 1. 1 times 1 gives you 1, and 1 plus 1 gives you 2. So therefore, I can now rewrite this. I can now factor this as x plus 1 times x plus 1. And then negative 3 minus 1 is going to be a negative 4. Well, ladies and gentlemen, x plus 1 times x plus 1 is not really going to help us out. That's not what vertex form is. Vertex form was a binomial squared. So remember, if you have two binomials that are multiplied by each other, you can write that as x plus 1 squared minus 4. Now we have a function f of x, not in standard form, but now it has been rewritten in vertex form. Now we have that binomial squared minus 4. So now the vertex in this case, vertex is going to be negative 1, negative 4. Ta-da, done. OK, so now let's go and move into the next one. You can see I isolated them. I'll kind of move a little bit quicker here. So I'll do b divided by 2, square it. So therefore, I have negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is equal to 4. So now I'm going to add 4 to the inside, and I'm going to subtract it to the outside. So I end up with x squared minus 4x plus 4 plus 1, and then minus 4. Well, now I need to factor this out. And you can always use the cross method. But basically, the same thing we're asking is what two numbers multiply to give you 4, but then add to give you negative 2. And that's going to be negative 2. So it's really x minus 2 times x minus 2. Well, in reality, we can just write that as x minus 2 squared. So I can write this as x minus 2 squared. 1 plus negative 4 is going to be a negative 3. Now I can determine that my vertex, in this case, is going to be h comma k, which will be 2 comma negative 3. All right, so now we're going to get into one that's a little bit interesting. So in this example, we have a as 1. But now when we take b divided by 2, so I take 5 divided by 2, and then square it, well, we have a little issue here because 2 does not evenly divide into 5. Do not use decimals. Keep them as fractions. It will make your life so much easier. We can still do this. 5 divided by 2, can't simplify that any further, so I'm just going to square it. 25 over 4. I'm still going to add those numbers to the inside, and I'm going to subtract it to the outside. So when doing that, I now obtain x squared plus 5x plus 25 over 4 plus 2 minus 25 over 4. Now, a couple of things that I want you guys to understand. When we are simplifying them, whenever we're doing, whenever we're factoring this, because you might say, I have no idea how to factor this. What am I going to do to factor this? Well, it's really important that the factored form is always going to be x either plus or minus. It depends on what the value is. But x plus or minus b divided by 2 squared. It's always going to be that way. So really, it just depends on or actually, I could always just do it as plus. So it's always x plus b divided by 2. Well, if b was negative, then it would be x minus. So in this case, let's see what was our b divided by 2. Our b divided by 2 was going to be, our b divided by 2 is just 5/2. So I could go through the whole factoring and do the x and everything like that. But guess what? The factored form of this is x plus 5/2 squared. Now, the only difference here in this case here is we have a fraction. And we have a 2 minus 25/4. So how are we going to go ahead and determine that? Well, the best thing you need to do whenever you have a whole number minus a fraction is to rewrite your whole number as a fraction. Now, to subtract, you have to get common denominators. So I'm going to have to multiply by 4 over 4. And what that's going to give me is an 8 over 4 minus 25 over 4. Well, now I can subtract the fractions by subtracting the numerators and keeping the denominator same. And what I end up getting here is going to be a negative 17. So it's actually now going to turn into a minus 17 over 4. So now I can label my vertex just using my h and k. Negative 5/2, comma, negative 17 over 4. Okay? So you can look into factor, and let's just double check this real quick. 5/2 times 5/2 is 25/4, right? You multiply straight across. 5/2 plus 5/2 would be 10/2. 10/2 is 10 divided by 2, which is 5. So that's the factored form. It always works. X plus b divided by 2. Remember it. All right, so I'm going to use that again in an example in this case. But in this case, did I not? Okay. Well, now we have a little bit of issue. Because remember when I first started this, I said when you're completing the square, a always has to equal 1. Well, now a equals negative 1. So what I have to do is I have to factor out that negative. So I'm going to factor out the negative. And that's going to leave me with an x squared plus 8x. However, I am only going to factor out the negative out of my first two terms. Because those are my only two terms that I'm going to be concerned with at this moment in time. Because remember, that's all we really do. This negative 3 just kind of stays there until we combine it. The 1 kind of stayed there until we combined it. The 2 stayed there until we combined it. So we're only really concerned about completing the square inside those parentheses, right? So I'm only going to factor out the negative inside my quadratic and my linear term. So now, when I go ahead and now I need to go ahead and do my b divided by 2 squared. So I take b divided by 2 squared. Just make sure you do the b divided by 2 squared that's inside your parenthesis that you factor that out. So therefore, that's going to be 8 divided by 2 squared. Well, 8 divided by 2 is 4. 4 squared is 16. Okay? Now, here's where it gets really tricky. And this is what mixes everybody up. So we're going to add that 16 inside of our parentheses, right? Everybody kind of remembers that. So when we're adding it inside the parentheses, it's really, really, really important for you to understand that when I'm adding this inside the parentheses, this whole parentheses is being multiplied by a negative, right? If you apply distributive property, when you factor out the negative, you apply distributive property to redo it. So I'm really not adding a 16 on this side. I'm actually adding a 16 that's being multiplied by a negative 1. So you can think about this a whole bunch of different ways, but the best way I like to do it is still follow the add and subtract. So if I add 16 inside the parentheses, I subtract 16 outside the parentheses. But whatever is being multiplied by these parentheses, you have to multiply this number by. So that this parentheses is being multiplied by negative 1. So I'm going to multiply this one by a negative 1. Now I can go ahead and complete the square for this. Basically, again, it's asking what two numbers multiply to give you 16, but then add to give you 4. And we can determine that that's going to be negative x plus 4 squared. And then negative 16 minus, or negative 16 times negative 1 is going to be a positive 16. Positive 16 minus 6 is going to be now a positive 10. So now I have my equation from standard form to vertex form. I can now determine the vertex is going to be negative 4, comma, positive 10. Just note that the negative is now going to reflect the graph down, okay? But basically still the same. All right, so now let's go and get into the next one. Now the next one, we actually have a number in front, right? But we still got to factor that number out. So when I factor this number out here, I am now going to be left with x squared minus 4x. And I'm only going to, again, factor that out of my first two terms, because that's the only two terms, those are the only two terms that I can care about to create my perfect square trinomial. Now I take my b divided by 2 and square it. So I have negative 4 divided by 2, which I already did, dang it. Negative 4 divided by 2 is negative 2. Squared equals positive 4. So now I have x squared minus 4x, and then I'm going to add a 4, plus 3, and subtract a 4. But remember what I talked about. I'm adding a 4, but this 4 is being multiplied by 2. So if I'm subtracting a 4, that 4 also has to be multiplied by 2. Okay? You got to keep the function, you got to keep that equation or the function exactly the same. If you're adding a 4, but that 4 is being multiplied by 2, then when you subtract the 4, that 4 has to be multiplied by 2. Well, now you can see this is exactly the exact same problem. I didn't mean to do that, but we'll make that simpler. That'll be nice. And then here I have negative 4 times 2 is a negative 8, plus 3 is a negative 5. So therefore, my vertex is just going to be 2, comma, negative 5. OK, last example. Finally. All right, so again, we see that we have a number in front, so let's factor that out. When we factor this out, though, we're left with x squared plus 3x minus 1. Again, we got some nice little things that, again, now we have to, again, complete the square. So I'm going to take b divided by 2 and square it. So in this case, I have 3 divided by 2 and squared. But again, 2 does not divide into 3, so we're going to leave that as 9/4. Well, again, I need to multiply that 9/4, or I need to add the 9/4 inside the parentheses and outside the parentheses. So when I do that, I have 3 times x squared plus 3x plus 9/4 minus 1 minus 9/4. And then that 9/4 has to also be multiplied by 3. And remember that 3 is really basically like a 3 over 1, right? Yes. OK. So again, if you remember my rule from last time, all it is b divided by 2, x plus b divided by 2. So therefore, this factored form, the factored form of this is going to be x plus 3/2 squared. And again, let's double check. 3/2 times 3/2 is 9/4. 3/2 plus 3/2 is going to be 6/2, which is 3. Now I just need to do my fraction operations. So that becomes a negative 1 minus 27 over 4. Well, now I need to recreate 1 as a fraction with a denominator 4. Well, 4 over 4 is the same as 1. So 4 over 4. Now I have negative 4 minus 27 over 4. So my final answer is going to be 3 times x plus 3/2 squared minus 31 over 4. So my vertex is going to be a negative 3/2, comma, negative 31 over 4. So there you go, ladies and gentlemen. That is how you use completing the square to rewrite a function from standard form to vertex form. Thanks.